So, data encryption. That is a very complex topic because there's so many standards out there, and there's also a lot of new technologies that help you with this topic. However, I mean, let's touch base on the basics first. What is encryption, so that you can envision what it actually looks like? So it's basically scrambling data into code. I mean, data is code anyway, but obviously this piece of code can only be read with a key. Yeah? Which brings me to the first opinion that I have on this topic. So best encryption mechanisms don't help anything if you're not having a sophisticated key management, and that's even a prerequisite, you don't have a proper access management. So if you allow everyone to access your data and they can genuinely, with their login authorized, use the key and decrypt it, then it doesn't help you anything. Anyway, so looking at it from a point of view, what kind of data is interesting? To simplify it, there's always this thinking of data at rest and data in transit. Whereas sometimes it's also a bit fluid, because when you have interfaces that have a file that has to rest somewhere for a while before it gets transferred further, what is it then? Data at rest, or is it still data in transit, or is it temporary rest? At the end of the day, it doesn't really matter, maybe, because you have to look at it from an end-to-end point of view. And therefore, it's interesting, where is the data in the first place generated? So when you look at websites, the user keys in the data initially into some form, then press a button, then the data goes through the web server into the database. Then from the database, maybe into some middleware. In the middleware, it will be split, or filtered, and all these kind of processes. Then later you have to follow basically the data from the origin through the processes of calculation, filtering, loading, and then maybe it comes out later as a report somewhere that is then the final consumption. However, it stays as master data in a database. So ideally, to outlay the whole data flow, it makes sense to have a system diagram and mark the data flows and say, here's where the full record is generated, here it's merged with additional data. Ideally, also can mark if the data has been increasingly being sensitive after a certain step, because maybe you look up some information about the customer and you're adding it to this. So, but basically then, when it comes to encryption, so when you look at your system diagram and you have to decide what kind of encryption method I use here and there. Of course, the best is end-to-end, so that you say the data has been, that's what we call it, tokenized at the time of entry, and it will be detokenized every time when it needs to be really visible. But all the processing can handle in a tokenized way, so even when you do some splitting or adding of information, you can actually keep it encrypted. Nevertheless, looking at different layers of encryption, just for the background, so if you have to apply it on this technical diagram and see what kind of source you're actually there encrypting. So if you don't use tokenized data, you can still apply for each of these stop points. So network encryption, okay, fine. That depends pretty much on your infrastructure setup. What people better understand is this full disk encryption. So of course, if you have a server, even be it a virtual, in the cloud, there's still some kind of a full disk encryption function physically for the disk actually where your partition is, but also for your logical drive that you're creating. Then you can add additional encryption on the database, even down to column level, so that you can say this is a sensitive column. I would like to have that not necessarily visible to the database administrator. And when data doesn't go into a database, especially what I mentioned before, this data flow where you have like files generated that are moving around and going back and forth, you can also do it file-based or folder-based. So, for example, there's temporary files generated before they were uploaded to the next database. you can actually encrypt that as well. Of course, it's not a great technology to handle file-based interfaces. There's definitely better ways of handling it, but I always have to assume that you're not having the top-notch setup where you can just activate everything with a click of a button. You most likely have a mixed environment where some old stuff meets the new stuff, and therefore you may have to have some creative ideas how to also encrypt those. And application level encryption, of course, that's also something where I just mentioned via an API you can tokenize data at the moment of submission by the customer. That would be the ideal case, because then the data stays scrambled all the time, no matter which flow it goes, where it's saved temporary. Only with the detokenization mechanism it comes out again readable. And I say some fields, you literally have to go through your data catalog and say, do I really need all these fields at all time being readable? Or, I mean, even when your call center is handling some of the cases, do they really need to see the full record of the customer? Maybe name and phone number is good enough, and therefore you can actually encrypt the other things for long term, and only when you need that for specific business processes by very authorized users and very different views, it's then unencrypted for that very purpose. So what do I recommend? Having a multi-level approach here, because obviously, yes, full disk encryption is great, but if everyone has access to the disk, only the one that rips out the disk from the computer and walks away with it would not be able to read it. But technically, if they have administrator access, which is the more convenient way of hacking this, that would allow you to read the whole thing again. If you have a database encryption, well, if the credentials of the database administrator are the same as of the server administrator, you also haven't won much, because again, if someone can log into the server, they can automatically log into the database, all the keys will be applied, and the data becomes readable. So again, haven't won anything. You're literally protecting yourself against the ghost, because as mentioned, attackers usually try to get credentials of privileged users to gain access to the data. So as long as you don't protect your users properly, then everyone will have access to the data through their account. And it's not about how hard you encrypt it and what encryption protocol you apply. Different topic is quantum computing. People talk about it and say, well, in a few years there will be computers that can crack every code because they have so much calculation power and they're so fast. No key can withstand that. So there's people already researching on this and trying to find a way how to do that. Obviously, you will have to use one quantum computer to encrypt that another quantum computer cannot encrypt. So therefore, it's a bit of a never-ending story. You have to be always a little bit faster than the attacker, but not necessarily means that you have to apply the latest technology. Best way of protecting data is deleting data if you don't need it anymore, and if your data privacy policy anyway prescribes that you can only use it for a specific use, and the customer won't be happy about it if you keep it for other purpose, even for analytical stuff. Delete every sensitive piece of data, especially when it's personal identifiable. You can mask it, you can scramble it for good so that you can use it for analytics, but you don't need the actual personal records in there that identify the individual person in your data records. So therefore, so encryption very tied to access management. Also a topic on its own, how you ensure that, especially when you have multiple resources in different environments. Most people also keep it easy. Everyone has access to everything, or only a limited group of people, but they still have access to everything. You must start avoiding that. Otherwise, all your encryption efforts are kind of for the bin, and they will not help you when you have an attack, because the attackers come a totally different avenue than trying to crack your keys. Therefore, watch out for that.